Stars seem to be quietly standing still in the night sky, but did you know they're actually always spinning around? Each star you see in the night sky is experiencing angular motion or rotation around its axis. We can measure this using photometric observations of sunspots on the star, observing how the spectral lines of the star are shifting, or even by looking at the geometry of how we observe the star. So why do stars even rotate to begin with? When stars form, they first begin as a large cloud of interstellar dust and gas, which likely have tiny movements throughout space that have a slight initial rotation. If the clumpy cloud has enough mass, it can then collapse under gravity to form a protostar. After the protostar forms, it still maintains that initial rotation, but begins to spin even faster thanks to the conservation of angular momentum. This simple physics idea allows them to keep rotating throughout their lifetimes for billions of years on end. And then, as mentioned, this rotation manifests in the various ways that we observe the star. Understanding rotation is important because it leads to the creation of a magnetic field in the star. When stars rotate, the resulting Coriolis effect causes stellar convection to take a helical shape, so hot particles of plasma will rise to the stellar surface in a cyclonic-like motion. This is crucial for the strength of the magnetic dynamo, as it leads to stronger and more ordered magnetic fields. Essentially, the process of how kinetic energy is converted into magnetic energy is much more efficient. So, the faster a star rotates, the stronger its magnetic field will be. And so, if a star has a strong magnetic field, there's a higher chance for extraordinary magnetic activity like stellar flares, coronal mass ejections, or UV radiation, which in turn affects the environment around the star, such as the case of atmospheric escape or abiogenesis on exoplanets. Deeper into stellar astrophysics research, sometimes rotation can be used as a proxy for things like determining the ages of stars or tracing stellar history and seeing how angular momentum is lost over time due to stellar winds. But in general, understanding stellar rotation is key to understanding the broad behavior of stars and the role they play in sustaining life in the universe, potentially. If you want to keep learning more about stars, like and follow for more.